So here's one example of a similar triangle setup that I wanted to make sure I had a video to go over. In this case, we're going to be asked to come up with a similarity statement. We're going to be asked to defend why these are similar triangles and then use the fact that they're similar triangles to solve for x. So why is the first thing that I'm going to talk about, because that's going to help us with the similarity statement. These are similar triangles because of angle-angle similarity. That's great, but you can't state that unless you can give me two angle congruent pairs. That's not just this angle is congruent to this angle, but two of those congruent statements. Now there are all three, and we could get all three from this picture. We would only need two of them. But one thing you definitely need is the fact that these symbols here mean that QR and PT are parallel. Based on the parallel lines, you are now able to conclude that angle Q and angle T are congruent angles. Those are alternate interior angles of parallel lines. So I could make the congruent statement angle Q is congruent to angle T, but I need another one. And you can use the same concept, the same parallel lines, but use RP as your transversal now, and now angle R and angle P. Based on the same logic, they are alternate interior angles of parallel lines. Those are also now congruent angles. Angle R is congruent to angle P. And then defend Y, I can just defend Y here, since both are alternate interior angles of parallel lines. There is a third angle pair in here that is congruent, and it is true, and you could have used that, but I would not call it angle S is congruent to angle S. Again, just like we did first semester, I would number these and say that angle 1 is congruent to angle 2. You could use that along with one of these two, or just these two. It doesn't matter which two of these three, but you would need two of the three to prove with angle-angle similarity. Now, moving on or up into the similarity statement. Remember, when you're stating your similarities, your triangles have to be used with corresponding angles. So, however I name the first triangle does not matter. I, in fact, like to name this one corresponding angle pair at a time. And it all stems from your congruent statements here. We know that angle Q and angle T are congruent. So I might start with angle Q and angle T as the first vertex that I name in the triangle statement. And I know angle R and angle P are congruent, so I will put R and P second, but make sure Q and R are in the same triangle. And then angle S down there, angle 1 and 2. Now I have my similarity statement. Lastly, the similarity statement is what helps give me my information about my side lengths. Side lengths are not equal, they are not congruent, they are proportional. So when I am solving for x here, I utilize the fact that, well, here's one side that has an x in it. That is segment QS. Well, what does that correspond to? Look at your statement. QS corresponds to TS. So QS is 2x. That corresponds to TS. That's 8. Those are going to be a ratio. And then similarly, I know this side length is QR, so this is going to be equal to QR over QR corresponds to TP over 10. So that's what I'm comparing. That's the proportion I'm using. Now I can just substitute in the side lengths I know. I know that QS is 2x over TS, which is 8, is equal to QR, which is 3x minus 4, over TP, which is 10. Cross multiply and solve. So this would give me 8 times 3x minus 4. Don't forget to distribute. And 2x times 10. When I go through the algebra and solve here, and I'm not going to do that on the video, that's going to be up to you to remember how to do. but distribute my 8 and then move from there, we should get x equals 8.